Thanks very much, Stuart, and good morning, everybody. So I'm going to be your host now as we walk through ArcGIS 2022, our system and its capabilities. So our vision for ArcGIS is that it's a complete geospatial system that supports multiple communities. Now, many of us here today are part of the GIS professional community. It's our biggest and most established group of users. Or perhaps today you're part of the mapping and location services community. You're drawing ArcGIS capabilities into your own context. Or maybe you're a data scientist using powerful spatial location analytics to unlock patterns and trends. Or maybe you're a developer building your own apps. This was my story when I started out. Well, the great news for you today is that we're making the entire underlying ArcGIS platform as a service available to you. All of our tools and capabilities, all of our content and our data is available via an API. But it doesn't stop there. The way that you, in all of these communities, are increasingly using ArcGIS is to provide access to the public and to wider society, to people who've previously been unable to get access for reasons of complexity and cost. And that trend is growing. So what is ArcGIS? Well, one of the things that I enjoy doing when we have new starters here at Esri UK is we'll sit down in small groups and we'll ask this question. And I think the best answer is that ArcGIS is a set of capabilities, a set of things that we can make use of. It's not just a product, it's not just a solution, but it's this group of capabilities. And this set of things that we can make use of is growing, it's expanding. We're actively developing ArcGIS every day. And then when we come together in communities like this, there's always more to talk about and to tell you about. So that's what I'm going to do now. We're going to walk through the capabilities in ArcGIS 2022, and I'm going to make a few stops along the way to introduce you to some of my colleagues, Hannah, Abby, and Rob, who are going to bring this to life for us. So the first thing I want to talk about is the ArcGIS Living Atlas. It's the world's largest collection of geographic information, of tools, intelligence. It's things like maps, demographics, near real-time information, and authoritative data sets from us at Esri, from our partners, and crucially from you and the organizations that you represent. You are fueling one another's work with content in the Living Atlas. But it's not just about data. It's also spatial analysis tools. It's pre-trained machine learning models and other analytics. It's spatial intelligence that is available to be harnessed directly by your applications. You see, content is fuel for our maps and apps, and that content is increasingly tools and models that bring insight as well as data. And the Living Atlas brings all of this together for us. Mapping and visualization is probably the most tangible capability that we have in ArcGIS. Mapping is the language of geography. It's how we communicate geographic and geospatial information to one another. I can map locations, objects, where things are. And I can also look at patterns and interactions and how one object relates to another and what might be causing those trends and those themes that we see. A map is also a model, because once I've built it, I can test it. I can ask what-if questions of it, and I can use it to predict outcomes based on evidence that help me to understand the real world around me better and then make better decisions. And so ArcGIS provides us with a variety of tools and techniques here, things like access to rich base maps, smart mapping, story maps, dashboards, the ability to work in 2D and 3D, and to share and collaborate with one another. Spatial analysis is about extracting knowledge and uncovering patterns through geography. Sometimes seemingly random collections of data only really exhibit that intelligence through spatial analysis techniques. Now, what we're seeing is the area of spatial analysis expanding into the area of data science, taking with it traditional approaches like geoprocessing and Python, but also some newer areas like spatial statistics, spatial machine learning, deep learning, and GeoAI. Spatial machine learning, then, is where we can train algorithms to intelligently classify data and make predictions. These trained models can be used to automate the extraction of information from sensor data like imagery, point clouds, and videos. And we can also retrain these models to hone them for our own needs. And many of them are available in the Living Atlas, shrink-wrapped, ready to use. And we're going to see some of that in action just in a few moments. One new area in spatial analysis that I'd like to tell you about is the introduction of graph databases to ArcGIS. Now, graph databases model how entities are connected, and they help us to understand and explore those connections and the relationships between them, similar conceptually to how we model spatial relationships in GIS. Now, ArcGIS Knowledge puts a graph database inside the ArcGIS system, which then allows us to take advantage of these graph analytics techniques, which are common in scenarios such as supply chain mapping and crime analysis. Remote sensing allows us to collect data over large spatial areas, often autonomously, and build imagery and other information products that represent and monitor our environment and track change. Over the last few decades, remote sensing, imagery, and LiDAR have become a major part of GIS, whether it's tracking forest fires from space or monitoring building change detection, predicting crop production, or conducting site surveys using aviation like helicopters and drones. Remote sensing techniques are increasingly accessible to us. LiDAR sensors are quite literally in our pockets and have been now for the last couple of years in the form of the latest mobile phones. So we know that the variety and the availability of remote sensing data products is increasing rapidly. Now, ArcGIS allows us to visualize, analyze, and share these information products, and it also supports map and data production, as well as the management of all types and formats of imagery at very high volumes. To support this work, we've been working to make these capabilities available via SaaS, software as a service. So last year, we released ArcGIS Image for ArcGIS Online. It's a fully integrated extension to ArcGIS Online, which allows you to upload your data to the cloud, manage it, visualize it, and perform raster analytics. Now, ArcGIS Online itself is going to be 10 years old this year. Can you believe that? It's a decade old this year. But to me, it is mind-boggling that everything I've spoken about so far is now today available via SaaS, as well as on-premises. So we've talked about mapping, visualization, spatial analysis, data science. We've talked about machine learning and deep learning, and remote sensing and managing imagery and site surveying, map and data production. You can do all of these things via software as a service today. And actually, there's more SaaS to come, and I'm going to talk about some of these other areas shortly. But I think it's really important that we pause for a moment. This is a rich and powerful ecosystem. It is well worth seeing it in action. So I'm going to hand over to Hannah Fieldsend. Hannah is a data consultant working in our content services team here at Esri UK. And Hannah's just going to bring to life everything that I've spoken about so far. Hannah.
Thank you. So as we heard from Jason earlier, future climate change is projected to bring about a transformation in seasonal extremes. Now, Esri have long been vocal about the use of geospatial data to evaluate these climate extremes, to quantify risk, and to inform policy. Starting in this story map today, I'm going to focus on precipitation in the UK and carry out some fascinating imagery analysis using GIS in the cloud. According to its most recent UK climate projections, the Met Office found that whilst overall summers are projected to become drier, unfortunately, the intensity of annual rainfall is set to increase. So, for example, rainfall associated with an event that typically occurs once every 2 years could increase by up to 29%. This map shows a high emission, low mitigation greenhouse gas trajectory and where summer rainfall is projected to increase across the UK. It's these intense periods of rainfall where I believe we can deploy GIS to locate and investigate areas most susceptible to the impacts of these climate extremes. Next year actually marks the 30th anniversary of the Holbeck Hall landslide, an event I'm sure some of you in the room may remember as it piqued national interest after a period of heavy, prolonged rainfall triggered a slope failure and destroyed the Holbeck Hall Hotel in Scarborough. In 2 days, 1 million tons of sediment was lost. Next up, I want to show you the hotel in its former glory. So this Aerial Photograph Explorer, or APEX web app, was built by Historic England, who are here speaking on this today, using the JavaScript API. In the app, you can search for your area of interest and take a look through an archive containing historical imagery. So the app hosts vertical images, as well as, and I'm sure you'll agree, some beautiful oblique photography. So this photograph here shows Holbeck Hall and its grounds high up on the cliffside and was taken in 1947. If we take a look at the site today, using Esri's World Imagery Service, we can see all that's left is this scar on the landscape, and below it, some flood defences to prevent further ground instability. To link this climate story together with Esri technology, I'm going to investigate where future landslides could occur. I'll start with a single image and combine it with some other raster data sets in order to create a land susceptibility model for Scarborough. If you couldn't already tell, I'm a big fan of imagery and a huge advocate for its use within GIS. So by exploring this today, I'm going to show how ArcGIS Image for ArcGIS Online can host, manage, analyze, visualize, and share imagery, all within software as a service. I'll begin in my content in ArcGIS Online, and in here we can create a new imagery layer from scratch. I'll be uploading some 12.5 centimeter aerial photos collected by our data partners, Blue Sky. Using ArcGIS Image for ArcGIS Online, I can host this as either a tiled or a dynamic imagery layer, and this supports mosaicing on the fly, hosting collections of images, as well as an input for my raster analysis. I can choose my layer configuration, as well as the type of data that I'll be working with. So there's loads of different imagery types supported here, including that of some of our Living Atlas contributors, as well as our premium data partners. Widely used imagery formats, such as GeoTIFFs and raster datasets, are also supported. From here, I can load those Blue Sky photos directly from my machine. And just bearing in mind, this is around 60 gigabytes worth of data. Given the layer its name and some metadata, we've just created our own dynamic imagery layer in ArcGIS Online. I just want to highlight here that by using ArcGIS Image for ArcGIS Online, I was just able to upload 60 gigabytes worth of data in a matter of minutes. And I'm sure you'll agree, the output is a really beautiful orthomosaic photo showing Scarborough and its adjacent coastline. The area is a really popular tourist destination. It's home to a lot of high-value assets, such as touring and static caravans, holiday homes, and boats along the coastline. As a mosaic layer in ArcGIS Online, this imagery can now be used in web maps and apps and shared with other users in my organization, and that's a really exciting development for SAS. Now we have this imagery hosted, let's play around with some of the different bands using image display. So a common use case in Earth observation is using imagery to compare the visible and infrared light in order to measure surface vegetation. In the map viewer, I can modify our true color image by assigning the infrared channel to a different band. And ArcGIS Online is reconstructing this data on the fly and serving it back to me live as a false color image. And this is a really quick, on-demand way to identify different surface cover types for your analysis. I think this area highlights it really well. We've got a local caravan park where the false color has brought out the grass and the tarmac and shows the individual pitches. We can also use imagery to extract features, and instead of manually digitizing, we can automate this process by inputting our dynamic imagery layer, as well as choosing from one of the deep learning models available within the Living Atlas. So as Mark mentioned earlier, the Living Atlas doesn't just host data. To make sure your organization makes the most of the increasingly available imagery we can work with today, we've built a number of these models using AI to automate feature extraction. And we host them here in the Living Atlas as part of your ArcGIS Online subscription. This model extracts building footprints from high-resolution imagery. It's trained on USA data, but it works equally well for the UK, and you also have the ability to save these models and retrain them using localized data if you want to. And here's the results from that model. We've got a layer of over 10,000 building footprints. It was generated in just under 2 hours, created and hosted online. So from the Living Atlas selection of deep learning models, I've also run a land cover classification package. So from our one starting image, we now have a layer of built infrastructure along with a 6-class land cover dataset showing impervious surfaces and roads as well as varying vegetation cover. Okay, so I've shown how to create these layers as first principles, but I just want to emphasize the ease and accessibility of generating similar outputs yourself to your exact specifications. Now let's take a dive in some of the other raster analytics tools ArcGIS Online has to offer. As I mentioned earlier, prolonged rainfall caused 1 million tons of sediment loss in 2 days at Holbeck Hall. So I want to take a look at what might be at risk today. I'll create a process model in order to proactively locate what areas may be susceptible to landslides. As my inputs for this analysis, I'll be using a superficial geology dataset from our partners, the British Geological Survey, a 5-meter digital terrain model provided by Blue Sky, a distance to rivers raster dataset that I generated from that DTM, along with the imagery we previously created and have hosted online. So using the raster function editor, we can create process models within ArcGIS Online to analyze imagery. There's over 150 out-of-the-box raster templates to build functions from, or you can create your own using the editor. So my model normalizes those 4 raster inputs and then weighs and combines them based on the importance I've assigned each one into what's called a weighted sum. So the output takes a couple of minutes to run, and here is the landslide susceptibility output. It looks good, doesn't it? The areas in red show where the model has assigned the highest risk, and I can see this follows that underlying glacial till geology, which is also along the coastline and down these river channels here. To better visualize the relationship between landslide risk and elevation, I've brought this layer into a 3D scene. Here we have a highly susceptible area where I can see how risk relates to slope. If we add in those building footprints extracted from our deep learning analysis, we've quickly visualized some high-risk assets that aren't necessarily directly on the coastline. If we extrude those building footprints to 3D, we gain further context and we can see the buildings at the top and the bottom of the slope, which could potentially be impacted following heavy rainfall. Let's travel over to the seafront. And you can see here where that high risk persists all along the coastline and build up a picture of landslide susceptibility and where future defences should be focused. Where we are right now is in fact the view from where Holbeck Hall once stood 30 years ago. I hope you can see and be inspired by what I believe is just the beginning of hosted imagery and deep learning analysis using ArcGIS Image for ArcGIS Online, all within software as a service. From our one starting image, we have buildings, land classification, as well as an approach to seasonal extremes response that is more data-driven. The future development and expansion of British tourist sites such as Scarborough can now be more purpose-built, and as a result, more sustainable. Thank you.
Fantastic. Thank you very much, Hannah. You've just shone an incredible light, hasn't she, on everything that we've just been speaking about this morning. Let's move on and talk about some other capabilities in ArcGIS. So field operations and data collection is a core capability of ArcGIS, location enabling all aspects of fieldwork. Now, fieldwork takes a variety of different forms, so we need a wide and dynamic range of tools to assist us here. From a single user collecting rapid observations, perhaps along a transport network using quick capture, to forms-based workflows with Survey123, to our new comprehensive ArcGIS Field Maps application that allows you to do viewing and data collection, location tracking, work online and offline with sync, and really supports a distributed mobile workforce at scale. Field operations and data collection is inherently a spatial activity. And we've been working hard to build new capabilities in, such as the ability to work with sensors and high-precision GPS. But it's not all about those precision workflows. We're actually renaming the ArcGIS field worker user type to be the mobile worker user type, to reflect what we're seeing. 58% of all internet access today is performed using a mobile device. So this is about opening up access to GIS to more people at a lower point of entry and supporting those casual users and simpler workflows as well. ArcGIS allows us to model infrastructure and provides us with all of the tools that we need to capture, store, manage, and maintain our data sets. Now, when we're doing these things, the very nature of the information that we're working with is really important. So consider with me for a moment the attributes and the behaviors of utility information, where we're going to be doing things like modeling equipment and understanding connectivity and flow and performing analysis like tracing. That's going to be really different from, say, modeling an airport, where we're going to be interested in runways and taxiways and modeling these complex 3D airspaces, buildings, lighting, and other assets. That's why ArcGIS provides us with different information models for our different contexts, not only for utilities and airports, but for hydrology, roads, for pipelines, indoor mapping, and you can create your own as well. You see, the specific context that we're working in behaves differently, and so we need the tools and abilities to model those behaviors in every case. And because this is a web services-based capability, we can interact with it through browsers and mobile devices, as well as with traditional clients like ArcGIS Pro. Real-time visualization and analytics is about the tracking, monitoring, and alerting of continuously changing information. Now, this is becoming increasingly normal for us in our connected world. Sensor networks and IoT are all around us, whether it's smart cities providing better quality of life for citizens or smart homes with smart meters for energy usage. 1 in 3 of us here today are wearing one of these. A connected health monitor. It's everything from that through to real-time routing and logistics, unlocking the ability for us to replan operations on the fly. Now, all of these scenarios are based on a network of connected sensors and devices with real-time or near real-time information flows, either tracking objects that are moving around or stationary objects with changing attributes. The point is that real-time information provides us with the context to make the best decision at any point in time, which can ultimately save money, reduce waste, improve the environment, and save and protect lives. Here at Esri, last year, we released ArcGIS Velocity, an additional capability via software as a service that's integrated with ArcGIS Online that allows you to ingest IoT and other real-time data feeds and then perform on-the-fly streaming analytics as well as storing that data away for batch analysis later on. So I'm delighted to introduce this morning Abby Bourke. Abby is a senior consultant here at Esri UK, and she's working in the transport sector. Abby's been spending several months now working with ArcGIS Velocity, so there's nobody better to take us through it than you, Abby.
Thank you, and good morning. In the next 10 minutes, I want to talk to you about real-time GIS capability. And I want to show you how we can use only out-of-the-box configuration of ArcGIS Online, and in particular, the ArcGIS Velocity that Mark has just spoken about. To begin with, I'm going to show you how accessible it is to consume real-time data, and after which, we'll investigate how we can use this data to create a more sustainable transport network. something I'm sure we would all like to see. Now, to best illustrate how we can connect to an IoT sensor, I wanted to track someone making their way to the conference here today. Now, fortunately for me, 2 of our colleagues, Richard and Richard, are currently running late and are still making their way to the conference. They left Hemel Hempstead this morning in a beautifully branded Esri Tesla. And in the car, they had this small sensor device, just like this one. It's collecting information about the vehicle, like its speed, its bearing, and its location. Now, this is all available to us via an API. But I'm sure you'll agree that when we look at the raw data, it's not particularly friendly. So what we can do is use ArcGIS Velocity to bring that data alive within a map. Now, ArcGIS Velocity can connect to many different services, including the API that we're using today. Not only this, it can also consume a variety of different data formats, such as GeoJSON and XML. Its user-friendly interface will automatically derive the schema for me, lightening my load as I configure my feed. But to me, it is this next step which I find to be the smartest. This is where we're telling ArcGIS Velocity not only how to interpret the geographical data, but also the temporal one. This means that we are always looking at the latest location of the 2 Richards in their vehicle. Now, ArcGIS Velocity has 2 ways that it can receive updates for its data. The first is where we stay continuously connected, and as soon as there is an update, it's immediately received. The second, and what we're using today, is where we regularly poll the source, receiving updates at that point. Finally, on saving the data feed, we also create a stream layer, which we can then add to our web maps and scenes as we would our other layers. So here we have it. We can see the Richards making their way to the conference here this morning. But how do we know that this location is correct? Let's give Richard a call in the car and see how their journey is getting on. Morning, Richard. How are you?
Hello. Doing well, thank you. How are you?
How's the journey going?
Pretty good. We were stuck in a little bit of traffic, but we're just joining the motorway now.
Ah, perfect. So we're not far behind you on our tracker. Do you want to turn around and just show everyone what you can see?
Yes.
Ah, that's great.
We're just going over the motorway now.
That's cool. That really lines up with what we're seeing here. Perfect. All right. Well, hopefully we'll see you later then, Richard.
Yep. See you all soon.
Thanks, Richard. Bye.
See you. Bye.
So I hope this shows you that mapping accurate real-time data with Esri technology really is that accessible. Okay, so we know how simple it is to bring in real-time data, but how do we do something meaningful with it? The focus of the conference today is around using GIS to create a sustainable future. So what I want to look at is how we can use real-time data to reduce air pollution on the UK road network. I'm sure many of you are aware that it is the burning of fossil fuels that gives rise to air pollutants such as nitrogen dioxide. And actually, road transportation is responsible for 80% of NO2 concentration at our roadside. The effects of this are widespread, and poor air quality is actually the largest environmental risk to public health within the UK. And not only this, it then causes an up to £2.7 billion per year on its effect on economic activity. We're also seeing that it's damaging our natural environment, causing acidification and eutrophication of our soils and watercourses. But where is NO2 pollution? Now, this map showing data from EarthSense is NO2 pollution in 2019, where 30 places within the UK were consistently over the recommended levels set out by the World Health Organization. Now, I've got some sad news for any of you from Manchester. Your city was actually one of the worst when it came to air pollutants. But it's when we look at this in 3D that we can really start to see the concentration of NO2 with our roadsides, with the taller and lighter columns reflecting the ring road around Manchester. Now, this concern is compounded when we look at where the proximity of our homes are to major roads, as we can see here when I've added in Esri UK's 3D base map highlighting our homes. Now, recent studies have shown that exposure zones are 300 metres either side of our major roads. And for places like Urmston in Manchester, this means that 88,000 homes within Manchester fall within our exposure zones. With this information, we can then identify high-risk areas where we have a high proportion of people living within our 300-metre buffer. But how do we tackle air pollutants in this area? We know that there are long-term strategic plans in place. There's electric vehicle schemes, National Highways Air Quality Improvement Strategy, and governmental investment in greener travel. But could we use real-time data to start tackling this problem today? So let's imagine it's my job as a transport planner to reduce congestion in these areas. I know where all my high-risk areas are in Manchester, as we can see here in red. I can then use real-time data, such as that collected from Waze, to see where road users are reporting congestion events. And I also know where my on-road resources or traffic officers are, who can attend those sites and help clear the congestion, such as by removing a broken-down vehicle in the carriageway. All I need now is a mechanism to be able to tell them what's happening and where they need to take action. And for this, I can use a real-time analytic. So a real-time analytic is where we process and analyze the data as it's been ingested, triggering actions where appropriate. So in my workflow here, I have my Waze congestion alerts, which I am then filtering to say only trigger the further steps if this event falls within our high-risk area. Once I have an event that fulfills this criterion, I'm then finding my nearest traffic officer, and I'm sending them a text message to say what's happening and where they need to attend. Now, some of you may have noticed that we do have a congestion event currently happening in the high-risk area of Urmston. And now that I have set my real-time analytic off, I'll receive a text message as if I was that traffic officer. Cool. So here we can see it, the text message they would receive knowing that they needed to go and do something. But not only this, we can also feed this data into an ArcGIS dashboard so that those within the control center know what's happening on the network. They can then also take action, such as carrying out steps like setting variable speed signs. Now, for me, this really shows how powerful Esri technology can be in automating data-driven decisions within our organization. So to conclude today, I hope I've been able to show you how accessible it is to map real-time data within a web browser using only configuration of ArcGIS Velocity and absolutely no development. We've then been able to analyze this data as it's been ingested, making data-driven decisions that will ultimately help us to achieve our sustainability goals today.
Great, thank you, Abby. It's just a great introduction to working with real-time data and ArcGIS velocity, isn't it? And seeing some of the analysis that we can do and the decisions that we can inform by doing that. So thank you. Great, Abby. I want to pick up by talking about an area that you've seen in action a couple of times this morning now. Hannah showed a landslip scenario in 3D, and Abby's just shown you the air quality in Manchester scenario. Both of them analysis scenarios as well as visualization. So 3D has surfaced across the entire ArcGIS system. You've seen it in the scene viewer on the web today. It's also available in the desktop in tools like ArcGIS Pro, City Engine, ArcGIS Earth. It's in mobile devices, it's in the runtimes. And really, all of this is underpinned by the OGC i3S Common 3D Information Model, which allows us to model 3D objects and meshes and voxels. And it's really this specification that underpins the consistency that we can provide 3D across the platform. In some newer areas, we're bringing real geography to game engines. We now have SDKs for Unreal and Unity game engines, which allow developers to bring living atlas content into their game environments and build these immersive experiences that are rooted in the real world. There's also lots of work going into water and weather visualization on the web, 3D web editing, interactive analysis, and BIM integration. And in fact, it's ArcGIS GeoBIM that bridges this divide between construction and GIS data and allows us to access authoritative information in Autodesk BIM 360 and the Autodesk Construction Cloud and bring it into our GIS by reference so that we can visualize all of that information in one place. Now, importantly, that preserves the integrity of the BIM system of record, but it also allows us to use our GIS to index and link together disparate information that might be spread across different BIM projects with otherwise no central coordinate reference. Closely related to all of these areas is the world of reality capture, which allows us to create photorealistic, geospatially accurate representations of the world at scale by combining two areas that we've already spoken about, imagery and 3D GIS, and uses photogrammetric processing to create information products like point clouds, digital surface models, true orthos, and meshes. Now, we're integrating the Shore for ArcGIS engine across all of our reality capture tools, things like ArcGIS Drone to Map and SiteScan, to ensure that we have consistency and higher quality outputs. Now, Rob Nichols is a customer success manager here at Esri UK, working in the AEC sector. And Rob's going to take us now on a European tour of reality capture, taking in some of the sites that I've spoken about of imagery, 3D, and BIM integration en route. So, Rob, over to you.
Thanks. ArcGIS has a breadth of capability with reality capture. I would now like to share with you how accessible this content is and how easily we can combine it. The term reality capture is relatively straightforward. It allows us to capture real life. It enables us to replicate the physical world and turn it into a virtual reality, a digital twin, if you like. I'm going to cover different types of hardware that collect this data, the outputs they produce, and how ArcGIS can be used to analyze, query, and model this content. So let's jump in and start our journey. I made my way to my nearest train station, which happens to be in Princes Risborough, Buckinghamshire. Here, I was able to use something I'm sure everyone has on their persons right now, a mobile phone. I was able to use this technology to generate a 3D scan of me at the ticket machine. Yes, this really is me at the ticket machine last week. Whilst I was there, I was also able to scan part of the platform and the track. It's worth saying at this point that ArcGIS has always been able to combine this data and analyze and ask complex spatial questions about it, but never before have been able to do so at such low cost using something so accessible in the web to the average user. This is where my virtual tour properly starts, as physically I went no further. So let us all travel to London together. Here we reach Golders Green train depot. Here we're viewing a mode of transport I'm sure many of you used this morning, the London Tube. In this example, our next piece of hardware used was a drone. Drones are now a common tool among many organisations. They're more accessible, it isn't difficult to get trained to be a drone pilot, and above everything else, they provide really accurate data sets. SiteScan for ArcGIS is our cloud-based photogrammetry tool. Photogrammetry is the process of stitching together photos to create one seamless data set. We're going to take a look at one of my favourite capabilities now. So moving across my iPad, we can use the SiteScan Flight app. Here we can use the app to plan our flight, and this will then connect to the drone and be used to fly autonomously. And now we move into the SiteScan Manager web application, and you can see here the hundreds of photographs the drone has taken. These have been processed to create our outputs. This is an orthomosaic 2D map, which gives us a much detailed base map for our site. Here is a point cloud view for an accurate digital twin for us to query against. And in this example, we're going to analyze the profile of the roof. Further tools like photo inspection, volumetric analysis, and cut and fill are all part of SiteScan for ArcGIS. Mark Enzer touched on earlier that building sustainable infrastructure is a complicated process. Vital data that holds important project information is hosted in multiple systems, making access to this information difficult. Esri's new ArcGIS GeoBIM app has a direct connection to Autodesk cloud systems. Data such as drawings, models, and files hosted in the Autodesk world are accessible directly via GeoBIM by linking these two systems together using geography. Here we can view the overall engineering plans of Golders Green. And in this next example, we can drill into a 3D model of the signal box. This is being viewed in the Autodesk 3D viewer. And we now have a direct connection to view all of our design content alongside our virtual reality in one place. Moving to a different country now, our third stop is in the Netherlands, in a city called Utrecht. I'm sure many of you have visited this city in real life. We now have our third method of reality capture, a plane. Similar to a drone, it has flown over the city and captured thousands of images. Processed like the drone data, we have this beautiful 3D mesh of Utrecht. Did you know about 1/3 of the Netherlands is below sea level, and so with the risk of rising seas, flooding is an ongoing concern. In this example, we're going to explore the impact flooding might have on the city. Here you can see the watercourses running between the buildings, and using traditional GIS techniques, we can predict where the water might rise to in a severe case. For added realism, we can even apply the appropriate weather effects. What we haven't been able to do with traditional techniques, however, is combine our captured 3D reality and begin to highlight those buildings which will be impacted. This gives us total oversight of the effect of flooding in the city of Utrecht, providing planners an accurate representation of the impact of climate change on our cities. Next on our tour, in a town in Germany called Oerlinghausen. I'll be very impressed if any of you visited this remote town. Here we can view the road network. And as you can see, we have a tunnel ahead. Using our fourth method of data capture, we can bring in raw LiDAR data that has been captured using a mounted scanner on top of a vehicle. This generates an extremely accurate and dense point cloud. Whereas in our previous example so far, where we've used photogrammetry, LiDAR uses lasers. The result is not always a pretty picture, however, our output is all about accuracy. LiDAR can have sub-millimeter accuracy. Nowadays, LiDAR devices are slim, lightweight, have a lower price point, and are highly efficient in capturing assets, making it a much more attractive method of data capture. So what we're seeing here are millions of data points on the map. Each pixel has its own value, which can depict its true color, and it also stores its own coordinates. So put together, we have this extremely detailed data set that we're viewing in the web. We can accurately measure things, like distance between 2 points. And we could use this point cloud to enable surveyors remote access to this data. For example, they wouldn't need to close off this entire road to do inspections or conduct surveys, as we have sub-centimetre accuracy. In our penultimate stop, we visit Vienna in Austria. Here we have a 3D mesh showing off the capital. I can virtually explore all the sightseeing locations. And visit all the local landmarks. It's a beautiful city, I'm sure you'll all agree. In this example, I might start making use of Esri's new shadow analysis toolset. So I can select today, 17th of May, and set the time to coincide with our conference. And the tool will go away in the web and run this analysis. This isn't a separate layer, it has been run directly in my browser. We can also ask the map to provide us with detailed analysis of the shade. So, as I'm hovering my mouse over different parts of the city, it's giving me immediate feedback on how long particular areas are in the shade for between those times. Great for planners and urban designers who are under constant pressure to build sustainably. They can use this to look at ambient heating of buildings. They can use this to look at solar potential, and even as cities continue to warm up across the planet, shade is really important for the people that live and visit there. Before heading home through Germany, we can visit the historic city of Munich. We have a complete digital twin of this city using the same methods we've seen before. Let's remind ourselves of what we're actually looking at here. This is an entire city-wide 3D dataset put together by photographs. It's so accurate we can use it for reliable measurements. We can overlay utilities from under the ground. We can add in live data, which is constantly being updated. And we have rich attribute information within each asset. In this example, I can zoom to a particular location and start exploring in detail specific details about this construction site. ArcGIS natively now supports IFC and Revit models, and we can publish these 3D assets directly into our web environment, giving architects and project managers the ability to explore different aspects of their building and visualize the things they need with the surrounding context of the site. What I hope is clear to you through our virtual tour of Europe is that reality capture offers unique opportunities in a range of sectors and industries. We can use scanners fitted to robots, cars, trains. We can use photographs from cameras that have been mounted to drones, planes, satellites, and take their outputs and overlay them as models of the world we live in. Advancements in computer vision, machine learning, and artificial intelligence are already adding new dimensions to reality capture. As we strive to become cleaner and greener, we need these extremely accurate digital representations to help us model, analyze, and visualize the impact we are having on our planet.
Thank you, Rob. Fantastic. Just a stunningly beautiful introduction there to reality capture, wasn't it? And also just a lovely way to round out talking about the capabilities in ArcGIS. So we've covered an awful lot of ground this morning. You can see we've talked about everything that's on this slide here. But one final question you might ask me is, well, how do we access those capabilities? We do that through the ArcGIS system. So at Esri, we wrap capabilities into products and apps that are specifically designed to support different types of work. And then we bring those together in the ArcGIS system, which is comprised of 4 key pillars. Let me just walk you through them. The first pillar is a desktop software pillar, where we have ArcGIS Pro and other workstation tools. So ArcGIS Pro is our professional desktop GIS. It's our spatial analysis and data science workstation. It's specifically designed to work with local data, to work with enterprise data, to connect into ArcGIS Online and work with OGC services. The second pillar is our server software pillar, where we have ArcGIS Enterprise, GIS infrastructure for your organization. This is where we take all of the capabilities and we deploy them within the enterprise, either on premises or in the cloud. Now, one recent advancement on ArcGIS Enterprise is the deployment option on Kubernetes, which sits alongside our existing options on Windows and Linux to provide you with more flexibility. Now, Kubernetes is a containerization and microservices framework. It's essentially a cloud-native operating system, which means that it's highly scalable, it's easy to deploy and manage with lots of automation and strong DevOps support. And there's also a new commercial model that goes alongside it that's based on users rather than cores to allow you to scale it as you need. Our third pillar is our software as a service pillar, where we have ArcGIS Online, the world's largest mapping and data sharing ecosystem. You've seen today more capabilities than ever before available via software as a service. And we're going to continue to add in SaaS capabilities because it broadens the access to GIS to a wider audience at a lower point of entry. And the final pillar is our platform as a service pillar, ArcGIS Platform, which takes all of the capabilities that we've spoken about today and it addresses the needs of developers by providing access to ArcGIS via an API. And there's a really simple consumption-based business model to support that as well. So the final thing I want to talk about briefly is the portal. It's really what brings together ArcGIS and allows it to operate as a single system. The portal is responsible for security, for identity, for sharing and collaboration, content management. And really, it's this that's the central hub and heart of ArcGIS. There's a portal available in ArcGIS Online. There's one in ArcGIS Enterprise. You can connect to it with Pro. You can build applications for it with ArcGIS Platform. And you can leverage services and capabilities from it, such as identity and content sharing, for example. So there we have it. That is the ArcGIS system. It's a set of rich and powerful capabilities available to be deployed on premises, in the cloud, or as software as a service, accessible via an API, and curated into targeted applications by us at Esri, by our partners, and by you. Welcome to ArcGIS 2022. I hope you have a fantastic day with us. Thank you.